and then share my screen. Okay, so let's see. I might be also a little rusty. I haven't done this. Okay, excellent. So just as a quick reminder, if at any point you need to say something or comment anything, what you can do if you need some time to type is just type those three dots so that I know that there is a message or there is a question coming, okay? So that I can prepare for it and I can slow down so that we don't miss any of the content. So let's look at our presentation today. The last time, a long time ago, but none of us remember anymore, we were talking about functions. We talked about functions like being the minions from the Despicable Me franchise, right? So you were Gru, the programmers, you are Gru, and then sometimes you need to create a specific tasks for your program to run because you need to call these tasks multiple times, right? And we're talking about how to make a pizza. So if you want to make a pizza, then you can go through all of the ingredients, go to the store, come back, put them in the oven, etc., and get your pizza. Or you could pay someone that already does pizzas all the time, every day, and then they just receive some information from you, and then they give you back your pizza, right? So that sense of receiving and giving back is what is at the heart of functions, right? These things that we receive are called arguments. The things that we give back are returns, is the information that we return. Okay, so today we're gonna jump one step ahead and we're finally gonna start working in our first animation using Pygame. So Pygame is a special library in Python that allows you to create illustrations, create animations, and finally video games. So there's those three elements, right? Illustrations, animations, and then video games. So what is the difference between animation and video game? There's something that we have talked about before. Can someone remind me what is the main difference between animating something and making something a video game? What do you guys think? Can you guys hear me okay? Okay, remember, type it in the chat. So no voice. Excellent. Okay, thank you, Claire. Yes, you cannot play an animation. Excellent. Yes, that's exactly it. So animations don't receive input from the user, right? So recently I downloaded a new video game that is called Resident Evil. I didn't really, but I played it when I was a kid. So basically you are this tiny character in a world and you decide where to go, right? And the way you do it, if you interact with it, is by giving input to your machine. That's exactly what it is. So in order to start with video games, we first need to work with animations, right? So we need to learn how to animate before we can receive input to those animations. So what we're going to be doing today is our first animation using Pygame. So this is how it's going to come up. This is how we're going to divide it. First, we're going to talk about the design of our game. I'm calling it game as a synonym between animation and video games, and treating them as the same thing. Okay, so then we're going to see how we can make the first step by designing our data. So we're going to design our data. What do I mean by this? Well, we're going to see what essential elements have to be there in order to produce produce the elements that are going to have to come together. Okay, at the very end. Oh, no, gracias. Toque en la casa 202, ahí seguramente le dicen. Somos parte de la misma casa. Gracias, señorita. Feliz año. Sorry. Okay. Then we're going to have something called helper function. So we're going to define our data, right? And then based on that data, at that point, we are not even programming yet. We're just deciding, hey, what elements have to be in there so that at the end, we can put them together and then create the structure, create the program. So when we start creating that program, we're going to see that we're going to need some minions. We're going to have to say, hey, please, give me this information. I don't want to include it in the main script. I want you to process it for me, make it easy to digest, and then give it back. Right? And once I get it back, then I can just keep using it. You'll see what I mean by this. And finally, iterations. So these two elements, iterations and helper functions, are going to be the things that today's animation is going to be all about. And as you will see, all animations and all video games have these two elements in common. So I want you to meet Gizmo. So Gizmo is a small character that I designed 2 days ago for the sole purpose of doing this class. So Gizmo is just a character in its world, and what it does is just walking from one side of the screen to the other, right? So our game is gonna be based on the goal of making Gizmo move from the left side of the screen to the right side of the screen. But here is the important thing. I don't only, this is very similar to the frog that you animated, right? What I want you to do in this case, however, is to make Gizmo aware of its surroundings, is so that when Gizmo touches the edge, it says, oh, I ran out of space. I can't keep going. I need to go back, and then stay in the frame. So this is what I mean. So here we have Gizmo, okay? Gizmo is gonna move from the left of the screen to the right of the screen. So whenever Gizmo touches the edge, the right edge of my animation, of my frame, it's gonna say, oh, no, 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 I can't keep going. So it's gonna turn around and then it's gonna go on the opposite direction. So now notice that in terms of programming, a window is nothing but a series of pixels that start at this point. If I go on the left to right direction, I am affecting the X axis. If I go from the up to down direction, I am affecting the Y axis. Now, give me 1 second. I just want to make sure that no one's is waiting in it's in the waiting room. Okay, good. So it seems that we just don't have Willie with us today. Okay, so that is how we think about spaces in computers, right? So if you remember your classes in mathematics, so you have something that looks like this, and your instructor, your teacher asks you, hey, what is the x-axis? What is the y-axis? So x-axis is the left to right as well. And the y-axis is the up to down axis, right? It's the up to down direction. That is x and that is y. But in mathematics, you start graphing, or you start drawing your lines and stuff like that from this point right here. So this point right here is going to be the coordinate 0 in x and 0 in y. And the same way over here, you're going to have this point right here that is going to be equal to 1 in x and 1 in y. Okay. But in computers, in computers, and especially in the screens for Python, sometimes it changes, but not that frequently. What you are doing really is to invert this, and then y is 0 in y is going to be this point right here. So you're basically creating your chart like this. So you're saying, oh, this point right here is going to be the point 0 in x and 0 in y. This point in here is going to be 1 in x and 1 in y. So you see it's exactly the opposite. It's like a mirror, right? So Gizmo's position in the x position in the y position is going to be given by from this point in the screen. So this point at the very top left of your screen is going to be the point 0, 0. Now, these represent pixels. Pixels are like very tiny grids, right? When we talk about images, we're talking about pixels. How many pixels wide, how many pixels high is your image? And a pixel is the most essential unit of an image, right? It contains 3 different colors, three different values that are gonna be R for red, G for green, and B for blue. That is called an RGB format. Okay, and it belongs to a JPEG format of your images. There are other formats like PNG that accepts an additional, these are called channels. Okay, it doesn't matter, just they just want to give the information. So you have red, green, blue, and an additional layer that is called A or alpha, and that is transparency. Okay, so whereas JPG images don't accept transparency, PNG images do accept transparency. Okay, so it's just something that we need to keep in mind because we are going to use it today. Now, we know the objective of our game. So here is the most important question. Now, we see the illustration here of Gizmo moving from the left to the right. So I would like to ask you, in your opinion, what elements change in our program? What of these things that I just went through change in our program? What do you think? What changes in my program? Could it be, for example, in terms of, anything that you see in the screen, what do you think you are going to have to change in your program if you want to make Gizmo move from the left of the screen to the right of the screen? Okay, and do let me know if there is an answer coming. Just type the three dots. Okay, so I'm gonna ask directly. So how about the position in X and Y? Is that something that is not gonna change, or is it something that is gonna change? Gizmo's position in the X and Y direction, is it constant or a variable? What do you guys think? Okay, Dylan says a constant. Okay, we have an answer. What do you think, Claire? Is it something that we need to change? You can say yes or no. Do you think it's something that we need to change? Yes, maybe. Excellent. Really good answer. Thank you. Okay, so in this particular scenario, moving Gizmo is basically changing or updating its position in the x-axis. Right now, Gizmo could be considered to be, let me 1 second, what's going on here? Oh, okay. So here we have Gizmo, right? So I mentioned that this particular point, so this is the coordinate 0, 0. So at any given moment, Gizmo, or better say the image that represents Gizmo, this is going to be a PNG file, just an image that we load from our computer. The coordinate that we're going to be referring to as Gizmo is going to be here at the top left corner. So that is going to have an X and a Y coordinate. So X at this point could be something like 10. If we want to move Gizmo from this point to this point right here, or better say to this point right here, this is going to represent an addition to the 10 to the value of 10 that we have, whereas y remains constant. Okay, so notice that there is no change in y. Sorry, otherwise we would have Gizmo moving also down, but we don't see that. So x is going to change. So here, if we have a value of 10, we update it by adding to it a certain amount, and it ends up being 30, for example. Okay, and if we add another 20, it's going to end up being 50, and then 70, etc. Right? So that is going to give us the illusion that Gizmo is moving from the left to the right of the screen in a sequential way, in a gradual form. Okay, so that is definitely going to be a variable, and it's going to be kind of like the most important variable that we are going to need to think about. So x coordinates, and just for the sake of it, y coordinates. Okay, even though we are not really going to change the position of Gizmo in the up and down direction, it's just going to move left to right for now. Okay, there is another one that is very important. Okay, kind of like a graph. Yes, exactly. So what else do you think would change? And I'm going to give you a hand with this one because it's a tricky one. So I mentioned that we need to load images in order to make Gizmo move, right? So really there is no Gizmo. All we have is a series of still images that are piled next to each other, give the illusion of motion, okay? Otherwise Gizmo would be moving, but it would be still, right? It would just be, like a brick moving from the left to the right. That's not what we want. Instead, we want Gizmo to have this kind of like movement, of the paws, of the legs. So those are called the sprites. The series of still images that we pile together to create the illusion of animation are the sprites. So something that we also need to change is the sprites for Gizmo's direction. Okay? So it's going to be the sprites. So at first it's going to be just still, then going to move its paws to the right, then to the left, etc. But we are updating still images. So on the other side, what doesn't change in your game design? What things do not change in your game? What do you think? So we know we change X and Y position. We change the images of Gizmo. What are we not changing in this program? What things stay the same during our animation? What do you think? Let's start by the window. The size of the window. Do you think that's a constant or a variable? Constant or variable? What do you think? The size of the window. What would the size of the window be? A constant or a variable? Okay, we have Nylon says a variable. Okay, so in this particular scenario, the size of the window doesn't really change, right? Because if it did, it would be like, imagine when you're playing a regular video game. You know, the screen is always the same size. And then you're just moving through the screen, but the size of the window is always the same. It's not getting smaller or bigger, because that would be weird, right? So in this particular case, and well, in all cases when you're making animations and video games, especially video games, the size of the window is window size is a constant. It doesn't change. And what I mean by window size is this area right here, this rectangle right here. So that doesn't change. Okay, what else doesn't change? What else do you think doesn't change? Let's look at Gizmo again. I mentioned that we have a series of still images. You think that they all should have the same width and height? Yes or no? Should all of the images of Gizmo have the same height and width? Yes or no? What do you think? Yes or no? Okay, Nilon says yes. What do you think, Claire? Should all the images of Gizmo look the same in terms of height and width? So let's think about extremes in this particular scenario. Like, for example, I had a very tiny Gizmo and the next one was gigantic. Would that make a problem in your animation? So in this particular scenario, okay, good. So in this particular scenario, the Gizmo's size is the other constant, okay? And let's look at it over here. So we're gonna have Gizmo again over here, and let me erase these things. I'm not sure if I can. Huh, weird. Okay, so here on Gizmo, we have basically a rectangle. Okay, Gizmo's image is just a rectangle. And then the rectangle has to always have the same width and the same height. That's a constant. So that even though Gizmo changes its sprites, all the sprites have the same dimensions. So that when we change them, it doesn't, break the optical illusion that it is the same entity. Otherwise, it's going to be like, oh, he grew, or she, and then it shrank again. We want it to be constant. Okay, I don't chit chat. So let's look into a Replit for this. So what we're going to have to do is first to create the definitions for the X and Y's position. Then for the sprites that we're going to be loading into Replit, into Pygame, and then finally define some constants for the screen. So that's what we're going to do first. So we are about to start coding together. So first, I want to show you this that I call the winner's recipe for making video games. Okay, the first thing that you always need to think about is creating your data definitions. And what I mean by this is understanding what your variables represent in your game so that we can use them to create more complex definitions, more complex elements, variables, and finally use those in your program directly. So that is the step number one. Create your data definitions using atomic elements, aka primitives. So what are the primitive types? So you guys should remember by now. Integers, floats, strings, and booleans, okay? So those are the 4 different data types that we have in Python and in a lot of different programming languages. There you go, excellent. Strings, there you go, and integer, awesome, absolutely. So we're gonna use these ones, and then we're gonna pile them together sometimes to cluster them together in order to create new data definitions that we're gonna represent, that we're gonna use to represent our organism, an agent that is Gizmo. Okay, so and then that's the part of just thinking about your data. Has nothing to do with code. The second part is thinking about the code, and that is what things need to be looped over, right? In a video game, what things you need to loop over and over again? Well, basically the game itself, right? And for that, we're gonna use a forever loop. Hey, while the program is alive, while true, run, keep running, keep running, keep running, keep running. Oh, game over, break the loop. That's it. But theoretically, you could run the game forever, right? If you just pause it and go have some dinner and come back, it's still on, right? But there is other types of loops that we're gonna need. For example, running through each of the images of Gizmo so that we update it, right? That's not a forever loop. It's inside of a forever loop. But its job is gonna be to move through the different images of Gizmo, okay? So what requires to run forever? So what we're required to run forever is the whole game. Okay, what requires to run a specific number of times? Well, each of Gizmos sprite. That's what we need to run multiple times. Clear? Tommy, forward. Absolutely, yes. So this is very similar. But instead of calling Tommy with a specific method, so that dot forward is called a method, right? It's a function. This time, we're going to create everything from scratch. There's not going to be any infrastructure that says, oh, there is already a method that calls forward. We're going to create it today, right? So that's the heart of our programming powers at this point. So there is no Tommy. Yeah, exactly. And the reason why is because we're not using the turtle library anymore. So the way that we are using to draw stuff is no longer with the turtle. It's going to be with Python, which is more powerful. Okay, theoretically, we could also draw stuff with Tommy, but it would take more time. Okay, so I'm going to share this live session with you so that you can just join it. Let me discard changes and then copy this. I'm going to paste it in the group chat. So just click on it and make sure that you can log into your Replit account, and I'll see you in that live session. Okay, so you can see my screen. So I'm about to show it to you right now. So we're going to work through the data definitions together. That's the main goal of today. And we're going to have some fun with that. I'm actually really looking forward to it. So let me move this thing over. There we go. Okay, so right now I'm just waiting for you guys to show up in Replit. So log into Replit and then just join that particular that link that I sent you. Okay, just join the room. It's our live session room. If you guys run into any issues, please text me, send a message on the chat saying I need help, and then or type 3 dots so that I know that there is some feedback coming. Okay, I see the first person. Welcome, Nilon. Excellent. And then we're just waiting for Claire. Let us know, Claire, if you need some assistance, type the 3 dots. And if things go really bad, we can stop the recording and give you some troubleshoot. But before that, are you about to log in? Keep me in the loop. What's going on? Claire, can you still hear me? Okay. Sorry, it won't let me in on my school computer. Okay, take your time. Take your time. Now, let's give it another 2 or 3 minutes so that you can join in. If you can't join in, try to log into your computer because otherwise texting, like typing in your iPad is going to be really, really tiring. You know, it's going to be frustrating even. So yeah, in your computer because you have the keyboard there. Mhm. Okay, I see that Nilan already erased the information that I had. Please bring it back, Nilan. Yeah, just type Control Z until it appears again. There you go. Yeah, feel free to type stop. Yeah, right there. No worries. While we wait for Claire, and yeah, like feel free to play with it. Is very glitchy. Okay, no problem at all. So I'm recording these lessons, so you're gonna be able to go back to it and then just debug yourself. Alrighty. So no pressure there. But I would love to have you in the chat in the replit so that you can finish or work with us in the data definitions. That would be really good. No problem. No worries. What do I do, says Neon. Okay, so the first thing that I want you to do, here is a good challenge. Okay, so you want a challenge, good. So I'm gonna type you our first data definition. Don't worry, Claire, I'm gonna let you do the other one. First, this one we're gonna call X. Okay, this is gonna be the X data definition. What I mean by this is this. This is how it's gonna look like. Wait a minute, what's going on here? So this is gonna be X equals to int. That means that X equals to an integer type, an integer data type. So the way that you think about it, interpret a position in the x-axis of our game. Okay, now let's work in the definitions. X0, what is the minimum value? Actually, let's call it X minimum. I want you to give me three numbers, X minimum, X1, and X max. And X max, okay? So I want you to give me three numbers. The first one, X min, should represent the minimum value that you could have in your game in terms of position in the screen. X1 is going to be 1 point in the middle, and X max is going to be the maximum point that your game can have in terms of access. Can you send me the link again? Yes, absolutely. I'm going to do that right now. So 1 second. There we go. So I just pasted it in the group chat. Okay. Good. I like your intuition, Anilon. So in this case, we don't need to use Tommy. I just need you to give me three. No, oh, you're doing something else. You're already done. Good. No worries. No worries. Keep doing what you're doing. Okay, there you are, Claire. Excellent. Now we can proceed. Now, let's start talking about the position in the X direction. So as I mentioned before, the minimum value that we can get is actually 0. It's at the very top left side of our screen. That's the minimum value. So we can't have anything before 0, because if we do, that means that we are going away, like we are getting out of the screen on the left direction. That can happen, right? X1 is just a point in the middle. That is can be limited by what the screen size is. So you think, well, you know what? I guess I really need to know how big is my screen in order to know how many points in the X direction I have. So let's create a constant. Let's create constants. Constants, there you go. So the first constant that I'm going to create is a screen size. A screen. There you go. And I'm going to represent it as a tuple. We talk about tuples, so like a special list. It's going to have two elements. The first one is going to be the width. And this one, I'm going to define it as being equal to 640 pixels width from left to right and 820 pixels high. So that's the size of my screen. Now, here I gave you the first data definition, is 0. X minimum. Now give me one X, Claire, please create a new a new example named X2 in line 14 that is between 0 and 640. It's up to you, between 0 and 640. And Nilon, please create a third example called X3 that is going to go from 0 to 640. Okay, X3 equals, excellent, good job. So these are going to represent Gizmo being somewhere in the middle of our screen, right? But let's think about what is going to be the maximum value that Gizmo can take. So for now, I'm just going to leave it at 640, right? Or instead of typing it myself, 640, I'm just going to say, hey, take the value of the screen and make reference to the first value of that variable screen, which is equals to 640. Okay, so this is equal to 640. That's all we're doing. Okay. Yes, I see a comment or question coming from Claire. Excellent. I'm going to go a little slower. Now, let's create a data definition for the y-axis, the up to down. So I'm gonna create a new data definition here, data def, y, oops. And then I'm gonna do exactly the same. Y equals integer, where the computer chooses a random number. Is there a thing like random? Yes, good question. Yes, absolutely. You know what? Let's do it. Actually, that's such a good question. I want to go back to it at the end because I want you to incorporate randomness once we have finished developing the program. That's keep that question in mind. I'll do it. Okay, so this is gonna be a position in the y-axis of our game. So you can see that it looks exactly the same, right? It's very similar to X. So instead of calling it X, we're gonna call it Y minimum. So please, Claire, finish the value, give a value to the Y minimum. Has the minimum value, has to be the minimum value that the Y axis can take. What value do you think that is? Nilon, please complete the Y maximum. That's the maximum value that you think we can give to Gizmo. And then I will work with the y1. So, okay, so for me, it's going to be 400, right? And another one, y2, it's going to be equal to 600, something like that. Okay, I see a comment coming, comment or question coming from that. Okay, oh, wow, you gave us a really big number. Remember, yeah, so type it because, yeah, just type it. Okay, so I see you, Nilan, working on the maximum value. So think in the same way that we work on the X max. So you are gonna reference the screen and you're gonna reference the Y axis, right? What's the value of the Y axis? Well, it's 120. So the maximum value that it can take is 120. My computer shut off because of battery. I'm sharing it out. No worries at all. So what I'm gonna do while you turn your computer on, don't worry about it. I need to keep moving. So I just want you to follow along, okay? And whenever I need some feedback from you, instead of asking you to write the code directly, you're gonna give me the answer in the chat, okay? So until your computer reloads. So, so what is gonna be the Y minimum value, Claire? What is gonna be the value, the minimum value that the Gizmo can take on the up and down direction? What do you think? Okay, and Nilon, so we're gonna reference to the screen and 1, and this is gonna be equal to, and please put in the comment what's the value of the Y direction. It's right there in line 7. What is the value of the screen in the position 1? So Claire, what's gonna be the minimum value? Please type a number in the chat. Is it gonna be 1? Is it gonna be 0? Is it gonna be 200, minus 10? What do you think? No problem. Take your time. So I need to see the screen clearly, but oh, my screen is blurry. Okay, no problem at all. So the y minimum value is the same as in x. It's going to be 0. Remember, we're referring to Gizmo's position as a point in, in a space, and the minimum is at the very top left corner. That is the coordinate 0, 0. Okay. Now, in the case of Nilan, yeah, no problem. So in the case of Neon, so go to the screen value in line number 7, and you're going to see two values. One is 640. That one's for X. The other one is for Y. Because we're working with Y, we see that the value is 120. So that's the value that should go here. Right? So that is going to be the maximum value for now. Good. So now we define a position for our agent. At this point, we're going to call Gizmo an agent, an entity in our game. We define a position for the agent to live in. What's the next thing? Well, let's work with the sprites. This is the interesting part. Now, if you look at the left side of my screen, you're going to see a panel with a tiny folder in there that is named Sprites lower score 64. So in there, if I click on them in any of those, you're going to see a still image, for each of the different directions that Gizmo can take. So we have a total of 3 animations for each direction. Like if Gizmo is moving to the right, there are 3 animations. If it's going down, there are 3 animations, etc. So we have a total of 3 times 4 because we have right direction, down direction, left, and up. So we're going to have a total of 12 different images. So you can see them here on the right, on the left. Okay, so now what we need to do is to bring them into our program. We know they're somewhere in the computer. Now we need to say, hey, find them here. So that's going to be our next data definition. That is going to be called a path, simply the path to that particular image. The way we're going to call it is going to be like this: overscore and modulo. I'm going to explain this in a minute. So this is going to be simply a string data type. A string, remember, is defined by double quotes. Anything that you want to write as text goes in between double quotes. So this modulo can be one of the following. It can be R for right. It can be down for D for down. What's going on? There you are. It can be L for left. And finally, it can be U for up. There you go. Okay, so let me show you. What this means, this data definition does is a path to an image in my computer. That's all it represents, right? Before we think about how to load them or anything, we need to know just where they are. So let's create the first example. First, we follow the example I gave you here, path modulo. Okay, so path right 0 is going to be equal to, and is going to be equal to the current folder where that image is located. The sprite 64 and the name of the image. Oh, this is going to be right 0.png. Okay, then there is going to be a 1 at right 1. The only thing I need to change is the number here, and then right 2. That's it for the right direction. But now I need to create one for down. So now, Nilon, please create the data definitions, just like the 3 ones that I created here. You should create three examples of this data definition. One for down 0, one for down 1, one for down 2. I want you to tell me where the images for those particular sprites are located in my computer. So take the one that I made as an example. So you're going to have one that is path down 0, path down 1, path down 2. Okay. Okay, so what happened is that when you click on one of the images, suddenly you get stuck, right? There is no obvious way to go back to your script, to the main. So you need to click on main. So on the left panel, you just need to click back on main, and it's going to take you back to main. Okay, so we are working on the line 38. Line 38 is going to be for Nila. So I'm going to I'm gonna type it in. Yes, there you go. I want you to finish those data definitions. Look at the examples of how I did it using the three examples above, and do it for the ones for the Gizmos image down. Okay, and Claire, are you able to work to type stuff in the computer? Yes or no? Oh, yes. Were you able to hear? Sorry, were you able to? Are you able to type stuff in the computer? I would like you to finish the examples of this data in the in the in Replit. So what follows down is left. Okay, I see you typing. Okay, I'm gonna type that there. Okay, there are your examples, Claire. So I need you to do what Nilon is doing right now. So I just need you to tell me with a string where that particular image is located. That's what we are doing right now. Okay, so you need to go to the line 44, and then look what Nilon is doing. So you're going to take the example that I gave you in at the very top, the path R0, path R1, path R2, and you're going to do exactly the same, except yours is not going to say R, it's going to say L for left. Okay, so I just need you to tell me where in my computer these images are located and what they are called. And the way we do that is by putting it inside of those quotes. Okay, so excellent, Nilan. So I'm going to ask you to work on the last one. That is going to be path up 0. Okay, let's work on those together. Let's do it together. So you do the first two, I'll do the last two. Oh, I guess there is only 3. So okay, sprite 64, and this one is called up1.eng. There we go. That's the example. Okay. So we need to be very, very clear on the name of the folder. Otherwise, it's not going to find it. There we go. So I just modified it a little bit. Do I comment on something? Yeah, you can do it either way. So Claire, sprites 64 left. Yes, that's exactly correct. Exactly correct. There's just a tiny problem with the name of the folder, but other than that, that's exactly what we want. So now you just need to copy this, copy the ones that you made like that, and then just update. Instead of left 1, it's going to be left 2, and finish the one in the middle. Finish add to L1. Good, excellent. So we are ready. Now, the next thing that we're going to do is to load those images into Pygame. Now, this is the point where we start talking about Pygame. Okay, so let's wait for a little bit, just 1 minute. Yeah, so just paste it in there. Oh, well, that's, yeah, that's, I don't know what happens sometimes. Okay, so this is one. Okay, so there we go. So now let's move one step forward. Let's load this stuff into Pygame. This is the exciting part. Data definition, sprite. Instead of just a path to an image, it's going to be a sprite. So how did we define sprite? Let's call it SPR, and we'll follow the same nomenclature. It's going to be equal to a Pygame object that we're going to call by saying Pygame.image.load. Don't worry about it. I'll show you. We just need to copy and paste it. Interpret an image loaded into Pygame. representing a sprite. There you go. So let's work in the first data definition. STR R0 is going to be equal to what? Pygame. Pygame dot image is right there in the data definition. Dot load. And in load, we're simply going to call what? Well, the path to the image, right? So this is going to be R0. There we go. So that's all we do. Now remember, notice that we're going to have as many sprites as examples in the previous data definition. This is 12. Okay, so I'm going to work on the first one. Please someone work on the next one, which is down. Okay, work on SPR lower score D. So this is one. It's going to be equal to path one. Oops, sorry, over. So that's for the right direction. Let's work on the down direction. It's going to be equal to pygame load path down 0. D1, D1, there you go. And finally D2, D2. So that is right, then is down, then is left. Actually, I'm simply gonna copy this. Okay, what do we have? Excellent. So we have R0, R1, and we should have also R2, right? So SPRE should actually be R2, like that, right? Just to be consistent. Remember, you can call it anything you want. You could call it bananas or apple. We don't do it because it's gonna be easy for us to get lost if we add too many, too many stuff. So we need to be consistent. Okay, so now I'm gonna test one of my images. So what I'm gonna do is say, hey, while true, I'm simply gonna call the Pygame infrastructure, all the things that Pygame needs in order to run properly. So don't worry about what these things are because they are very specific to this particular library. So I'm gonna put them in line number 9 if you are interested, we wanna look at them. Okay, so what I'm gonna do is simply say, hey, you know what? At the beginning of my game, I want you to display and give me a color. Give me a color for the screen. And that color is gonna be in RGB format, which we talked about already. Is for red, excellent. So give me a value for red. Let's say something, yeah, it has to be a number between 0 and 254. So you can pick a number between 0 and 254. Okay, right here. So we need to give something like 30, 30, and 30. And that is in RGB format, you know, like a gray color. Then what should we do? We can then, give me 1 second. We say pygame dot, sorry, display dot bleed. This is something that you just need to memorize. This is nothing that, you know, like it's just very specific. It's a method. So bleed basically takes an image and places it into your canvas, wherever you want it to be. So what is going to be our image? Well, the data definition we just created. Let's call a sprite right, SPR R0. It's going to be Gizmo facing to the right direction. And I want to place it in an X and Y coordinate. I hope we had an X and Y coordinate. Oh, wait, we do. We just defined it, right? So we can give an example. I want you to appear in the X minimum for X. Oops. Oh, please bring it back. There you go. Excellent. X minimum for X and in Y minimum for Y. So if I run this, not yet, but if when I run this, I'm going to be able to see Gizmo rendered in my screen. In order to do that, I need to call something that is called pygame dot display dot flip. Okay, there we go. So now it should run. So before I move anything else, I'm gonna call clock.thick and I want to run it. This is gonna determine how fast my animation runs. Let's run it and see what happens. So it's say, oh, I'm just, waiting to update to modules and whatnot. So it's going to run in a minute. While we do that, Pygame is not defined. What we need to import Pygame, of course. So let's go to the very top. I'm going to say modules, and I'm going to import Pygame. Okay, so I'm going to run it again. There we go. So something is happening. And what happens? We have a screen right now. Oh, it says no file sprites -64, and that was an error with, oh yeah, there it is, with the address where these images are located. So I'm running it again. Sprite 64 op0 png. So it says that there is no sprites lower score 64 op0 png. Sprite 64 op0 .png. Oh, it should be there. Oh, it's the capital S. Should be capital S, the name of the folder sprites. We need to remember, Python is very, very meticulous with the case. There we go. So we have Gizmo right there. So you can see it. It's at the very top left. So it's in the minimum value that X can take, the minimum value that Y can take, and you can see that it's at the top left screen. Okay, so what would happen? And here I want first Nylon, then Claire, to change the value of X mean and Y mean. So pick one of the examples that we created and separate them by a comma. You can say, hey, I want XY, X1, X2, or X max. Pick your whatever you want. Here in line 84. In line 84, instead of saying X mean, pick one of the 4 examples that we created for X. Can be X min, X1, X2, or X max. Which one do you want? In line 84, where it says X min, just change it. And you know what, Claire, also change Y min in the line 84. While Nylon changes X min, you change Y min, okay? Remember, if you want to look at what example you can give, you can go back to the definition of X or Y, and we created multiple examples. We created an X1, X2, X max for X and Y. So you just need to modify it there. Okay, excellent. X max, sounds good. What do we have? My current glitch off and I glitch off the meeting. Oh, no problem. So good. So we have X max. Now I'm gonna modify it to say also Y max. Now let's run it and see what happens. Where do you think Gizmo is gonna be rendered? Let's find out. Whoop, where is Gizmo? Uh-oh, what did we do this time? Nothing's wrong. The program is running perfectly. You can tell because there is no error showing up in the console, right? No red letters. What is happening is that Gizmo's position is defined in the top left corner of its image in such a way that if you make the values X max and Y max equal to the top right corner of your screen, then Gizmo is out of the screen. So we need to update that. We need to account for that. So X max is not going to be equal to the screen in position 0. It's not going to be equal to the maximum width. It's going to be equal to the screen minus the width, the width of Gizmo itself. So we need to define it. We need to say, hey, how do I know how wide Gizmo is? So there are multiple ways to do that. I don't want you to worry about it. I can tell you for sure, and I can show you how to get it if you're interested in that. But for now, I'm just gonna paste it as constants. Okay, so if you go back to the very top, you're gonna see in the constants that there is a new variable that is called agent size X and agent size Y. So we're gonna use agent size X. Now, in the definition for the X value, what's going on here? I'm gonna get rid of that. At the very bottom. Okay, so in the definition of X, I'm gonna say, oh, okay, take the maximum value of X is gonna be the edge, the right edge of the screen minus the size of Gizmo. So I'm gonna say a screen at 0 minus agent size in X. The same goes for Y. It's going to be agent size, size in Y. And now, this time, if we render it, someone please do me the honors, play it, run it, and let's see how it gets rendered properly. Okay, so Gizmo is going to appear at the top left corner of our screen, but not outside. So I'm going to run it. And we should be able to see Gizmo somewhere down there. Where is Gizmo? I wonder if we moved something. Let me, so this is the reason why we create data definition, so that we can debug. So I'm gonna change this for a minute, X, Y, and Y1. X1 and Y1. Let's see what happens there. Oh, there's Gizmo right there at the very, very bottom. You can see it's, you can see it appears in the screen. Yeah, there it is. Okay, so what it seems that the only thing that's going on is just that our screen is too big, so we can't see it in the window that we have, but it's there. So X max and Y min. So I wanted to show at the very top right side. Let me see what's going on. Send link again, please. No problem at all. So let me see. Where is that link? I think it's this one. There we go. It's on the chat. Okay, so our window is gigantic. I need to make it smaller. Let me change the screen for now. I'm going to make it equal to, I don't know, something like 400 width and 600 wide. Let's see what happens. Oh, there it is. Now, Gizmo is on the right, just as expected. Good. So let's say Y max, just to make sure that Gizmo is not out of the boundaries of our screen as well in the Y axis. And it seems like it is. But I wonder if that's also a window. Want to make it smaller? 300. Oh, there it is. There is Gizmo. Okay, good. So we're going to have to keep the window this tiny for now. We will update it later. We usually don't do animations in Replit. We usually make them direct in our computers. Okay, so there we go. So now we can see that our sprites work. Okay. Oh, when is Kahoot time? Soon, very, very soon. We're actually almost done. We're ready to wrap things up. I just want to show you how to animate it now. So yeah, no problem. So now we have the sprites, the individual sprites, okay, defined. But now we know that there are sprites that, you know, create animation for Gizmo walking to the right. Then others that animate Gizmo walking to the left, other for top and other for down. So we need to cluster those sprites inside of a list that we are gonna run through in order to create the illusion that Gizmo is moving. So we're gonna do that right now. So let's create a new data definition in line 81. You can see that I'm typing there, and this is gonna be called loss_pr, list of sprite. This is gonna be called as this, loss_pr, and the modulo as well. Remember, this modulo just represents a comment. What is gonna be inside? Well, it's gonna be multiple sprites, right? As many as we want to create the animation. So this is gonna be a series of sprites that make an animation in one direction. That's all it does. So let's start with the examples. Please help me, Nilon. I'm going to start with the right one. Please name all of the different sprites that are involved in creating the animation to the right. You can take a look at the line 62 because that's where we define the sprite, right? And I'm going to work on the one below. So if you get lost, just follow my lead. So I'm going to say SPR B0, then SPR B1, SPR B0 again. I'll explain why in a minute. SPR B2. Okay, so that is for down direction. How about the left direction? Well, it's exactly the same, except instead of B, it's going to be an L. And finally, up. Okay, so I'm gonna go here, and it's gonna be U instead of L. D score up. Okay, so please finish the definition in the very first example, list of sprites to the right direction. So I completed the other ones. Just need to complete the first one. Okay, excellent. And then just update it, change the D for an R inside of those. Excellent, perfect. Okay, and that's it. We have the list of sprites that we're gonna iterate over to make Gizmo look like it's walking. So now at this point, we are ready to animate. We have all of our data definitions. Remember our winning recipe, define your data, done. Let's start talking about the programming. And I already gave it to you. Look, all of this is, this very small piece of code is the actual code, you know, all that what we need. But all that we are doing is running forever, fill the screen with black, then put Gizmo in there, and then just make sure that it runs at a speed that is visible to human eyes. So now, as it is, we have only one sprite, one Gizmo that is not animated. Let's animate it. So how do we do that? So for each of the sprites in the list of sprites to the right, notice each of the sprites is going to be first R0, then a sprite R1, then a sprite R2, R0 again, and then a sprite R2. Okay, so why did I put a sprite R0 twice? The reason why I do that is because it's part of the illusion of animation. If you walk to the right, then you catch up with your other leg, and then you start in the restful position. And then you go back to the right. You move your other foot, but then you go back to the restful position. Okay, so that's why I did it. The restful position is a sprite R0, the values with 0. Okay, so now for each sprite in the list of sprites in one direction, you can pick any direction that you want, but it has to be consistent with the direction that you want Gizmo to move. Then that's it. Just do whatever you are doing right now, just as it is. And instead of referring to one static sprite, you're going to say SPR. That's all. That's it. That's it. Now, if we run this again, sure enough, we're going to have Gizmo being animated. Look at that. Awesome. That's it. That's the principle of our animation. Okay. So let's, at this point, I'm going to take you back to my presentation. So you are in the, looking at my screen. We're gonna look at at the PowerPoint presentation. So here you go. So we need to make sure that we move our character from the left to right direction. So how do we do that? Well, the thing is that right now we automated the use of the different sprites in order to animate Gizmo. But what we are not doing is changing the position in X, make it go to the right, or reducing the position in X to make it go to the left. But in order to do that, we need to make an object that is going to be called the agent, that is going to represent Gizmo itself, so that it has an attribute, and that attribute is an X position. Okay, so I'm going to do that very quickly because I want you guys to go to Kahoot. And so look at what I'm going to do in line 89. And it's very straightforward because of where we come from, all the data definitions that we made. And on this one, I'm simply going to call agent. Okay, the agent is going to represent Gizmo. Or you know what? Let's call it Gizmo. Let's call it Gizmo. And then Gizmo is going to be equal to a dictionary. Remember, dictionaries are compound data. This is the second example of compound data. The first one was the list of sprites. But this is like kind of like the most compound data that we're going to define so far. It's going to have an X position. It's going to represent just a value in X, the one that we define. Value in Y. And finally, a list of sprites. Now, notice how I am referring to the data definitions that we built before. So this is going to be an agent in our game representing Gizmo. So why did I go into the trouble of creating a special element that represents Gizmo itself? Because I'm going to copy this in the example. You feel free to do other examples. This is going to be X minimum. Oops, X minimum. in the X value, and let's say, you know, Y1 for the Y value. And list of sprites is going to be equal to LOSPR R. Okay, I have all the examples already. It's easy to write. So now what I'm going to do is to modify my for loop. So in order to, instead of just going through a random, you know, direction with the sprites, I'm gonna refer to the direction of Gizmo. How do I do that? If you know how to do that, feel free to write, but I'm gonna write it right now. So for a sprite in Gizmo, and where in Gizmo? Gizmo list of sprites. There we go. Okay, so that's how we transform it. We are referencing now to Gizmo's particular direction. For each of the sprites, then, well, just do what you're doing. But instead of saying, hey, take X max and Y max, no, no, no. I want you to take the current position of Gizmo in the X direction and the Y direction. Okay, and with that, you'll see that Gizmo is gonna, if we run this right now, everything's gonna look the same. You know, Gizmo is still gonna be run, you know, at the top left, or it should. But what we're gonna change also is that we are gonna update. We're gonna update the value of X at the end of each animation so that we make Gizmo move to the right. So I'm gonna say, hey, Gizmo's X direction is going to be equal to its current position in X plus a value, let's say 10 pixels every time. Okay, so right now, let me say Y, just to make sure that it shows up. Okay, so I'm going to run this again, and if everything works well, there you go. Now you have Gizmo moving from the left of the screen to the right of the screen and then beyond. It just leaves us, right? It's not coming back. Doesn't seem to be wanting to come back anytime soon. Look at that. It's moving and it's gone. Okay. So check out your data definitions. They should make or start making sense now. And before we talk to the next step, let's go to our Kahoot so that we can take a recap. It's like bye-bye. Exactly. Yeah, yeah. I designed Gizmo to be kind of cute. That's why I put these gigantic eyes, right? So right now, Gizmo is doing what it's supposed to do. It's moving to the left from a position to the right, but then it's doing something that it's not supposed to do. It's not finding the edge on the right and saying, oh, I found the edge. I need to go back. It's not doing that. So in order to do that, we need to create a couple of new data definitions, actually modify the ones that we have. You're going to see how everything makes sense. Okay, so let's take a very, very quick, I wouldn't say break because it's not a break. We're going to take our Kahoot. So I'm going to share my Kahoot on the chat. So it's Kahoot time, and I'll see you in there. So give me 1 second. I'm going to give you all the links and stuff. So it's Kahoot time. Okay, so I'm copying the link. I don't know what blue kit is, but I'm gonna take a look at it. Sounds interesting. Okay, so there is the link. So you just need to click on it, and then you just type. Actually, I don't even think you need to type anything. I think you just need to click in there, and it takes you to the room. Okay. Okay, we have Claire. I'm all getting A. Good, excellent. So now that we're all in the room, can someone just say yes or no? Can you hear the sound from Kahoot? Can you hear the sound of Kahoot? Okay, thank you. All right, so let's start this in 3, 2, 1. Let's do that. It's a recap from what we just saw. And remember to mute your microphones. Let's start. Question number 1, why do we need functions? Red triangle to make the code easier to read, blue diamond to make the code more efficient, orange circle to be able to call it as many times as desired, or all of the above. Which one is correct? Why do we need to create functions? To make the code easier to read, make the code more efficient, make it be able to call it multiple times, or all of the above. All right, we have some answers. So, give me 1 second. Okay, good. So the correct answer is all of the above, right? That's basically what all of these things are reasons, valid reasons why we need to create functions. Awesome. We have some numbers on the board. Question number 2, true or false? Functions sometimes return a special type of data called none. I don't know if you remember this. Functions sometimes return a special type of data called none. So usually functions return something, right? Can that something be nothing? Yes or no? Yes, correct. Absolutely. I don't know if you guys were guessing, but yes, that is absolutely correct. Sometimes we call a function so that it does something that is unrelated to the current context or when you call it. We're gonna do it. We're actually gonna do it when we create our helper functions later today. What do we have here? I was guessing. I do appreciate the honesty. Okay, question number 3. In our game design, Gizmo is animated using what? Red triangle pictures, blue diamond PNGs, orange circle sprites, or green square, none of the above. Now, before you answer, keep in mind, I'm trying to confuse you. There are multiple things that could be correct, but I want you to give me is the one that is the correct answer, the most appropriate. How do we call the different set of still images that we use to create animations? There is a special name. Okay, excellent. Well, whoops. Yeah, that was confusing one because it's technically correct. But the reason why I didn't, give them as correct is because the special name that they receive is sprites. Okay, and I want you to think about them that way. Are not just regular images. They're just sprites. They're sprites. Okay, excellent. So question number 4, double the points, changes in the board could happen, which is not a constant in our game design, the X and Y position, the speed of our animation, the size of the agent, aka Gizmo, or the screen size. Which do you think is not a constant? Something that changes all the time. What do you think? Take your time. Oh, good. Good. One correct answer. Yes. So the correct answer is X and Y position. That's kind of like the whole thing, all of that we've been working on, right? Is updating the X position and defining that data. And so basically, if we are modifying, or creating data definitions for it, you can assume they are variables. That's the way it works. Okay. So okay, question number 5. Why do we need to know where are our sprites located in the computer? Remember, we need to call them from the computer. Why do we need to do that? Red triangle in order to save them, blue diamond in order to load them into Pygame, orange circle in order to keep them safe from modifying them, or all of the above. Why do you think we need to reference to where these images are located in our computer? What did we do with them later? After we do that? All right, so we have some interesting answers. So yes, so the correct answer is in order to load them into Pygame, right? That's pretty much all we did was tell me where they are so that I can call them and load them using Pygame. Okay, so we are not really modifying the image or even saving the image. We're just receiving it, taking it into our system and then using it to render our game. Okay, good answers. Question number 6, double the points, some changes in the board. Why do we need examples in our code? Why do we need examples in our code? X0, Xmin, Xmax, all of those are examples of your data definition. Hey, why do we need to make them? Why don't we just make one? Red triangle to make our code easier to read, blue diamond to debug, orange circle to understand the boundaries of our programs. Good, it's all of the above. Yes, so basically, like, you want your fellow programmers to understand what you're doing. And if you make your data definitions with a lot of examples, you also understand when your program doesn't run. Like when we found out that Gizmo was leaving the edges of the screen, right? So you need to think when designing programs where you can break them. Yeah. Yes. Okay. So good answer. So question number 7. Double the points again. Where in Gizmo's body is the coordinate X and Y that our program refers to? Here I put 3 red dots. Red triangle, it covers the entire rectangle. Blue diamond in the center of the sprite. Orange circle in the top left corner of the sprite. Or green square in the right corner of the sprite. Where in Gizmo's body is the coordinate X and Y that our program is referring to? What do you think? This might be a tricky one. That's why it's double the points, I guess. So because it covers, it covers the entire rectangle. It's just a dot in the center of Gizmo's body, is in the top left corner of the sprite or the image, or is in the right corner of the sprite. What do you think? Okay. All right, we have some interesting answers. So the correct answer is in the top left corner of the sprite, right? So that's the coordinate X and Y 0 relative to, sorry, not 0, it's just the coordinate X and Y of Gizmo. Okay, so if we change X, we move the whole image to the right, but X is always gonna be that top left corner for our sprite. Good. All righty, so question number 8. What happens when we subtract from our agent, aka Gizmo, X coordinate? What happens? Do we move to the left? Do we move to the right? Do we move down? Don't move, or the agent moves left? Where do you think it happens? Okay. What happens if we subtract from our agent's X coordinate? There is the direction in the screen. Do we move left, right? Okay, so what do you guys say? Agent doesn't move. Okay, so the correct answer, if we subtract from X coordinate, our agents should move left. Okay, so you can see here in the map, in the Cartesian plane, the X and Y, the diagram. So if we move to the left in the left to right direction, we are basically taking away from X. If we add to X, then Gizmo is moving right. Okay, and Y we are not even touching, right? It's up and down. Okay, so that's what happens. Question number 9. Double the points again. What type of loop should we use to animate Gizmo's movements in a given direction? We talked about the 2 different loops, right? You remember? Which one do we use to animate the different sprites that Gizmo has? A red triangle, while true, which is an infinite loop, blue diamond for loop, orange circle inverted loops, or green square conditional loops. Okay, so the correct answer is a for loop, right? So, oops, it's not here, but so basically for each of the sprites in the list of sprites for the right direction, basically render each of the sprites, right? So you need a for loop for that. So we're going to look at it back. We're going to look at it again. Misclick to the green to red, no problemo. So this is just a recap. Question number 10. In how many directions are we allowing our agent to move? Interesting question. In how many directions are we allowing our agent to move? How many? Remember our data definition. Okay, we defined the right direction, down direction, left direction, and up direction. In how many directions are we allowing our agent to move? Excellent. So even though we don't call the other directions yet, um, we are defining them. So technically, theoretically, we are allowing Gizmo to move in any direction it wants. And actually, as you'll see, we will. We're going to allow, we're going to give that sentient property to Gizmo where it can decide wherever he wants to go or she wants to go. Okay, so we are not going to limit our agent. Good. Last question, question 11. Defining the most simple data definitions first allows us to build more complex ones on top of them. Is this true or false? Defining the most basic data definitions allows us to build more complex ones by using them. Think about the X and Y directions. Okay, yes, that is correct. It's correct. So we define X and Y directions. We define the sprites. And at the end, we combine these three in one new data definition, which is called Gizmo, right? So Gizmo now has X properties, Y properties, and the list of sprites. So that's why. Yeah. Okay, excellent. So yes, I gave some of the answers away. Yeah. Good job, everybody. Yeah, so we are a little rusty, me included. No problemo though. Excellent. Good job, everybody. You did an excellent job. Okay, so no problem, no problem. Let's go back here. So here we have Gizmo. Now let's run it again, just because I really love how Gizmo moves. There it is, taka, 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 and then touches the edge, then it disappears, right? Oh, we're almost done, actually. So you know what? Let's leave this for the next class. And then, because it's going to be good that you think about this as a homework as well. Today, there is no homework. Today is lesson 5, so I'm just giving you homework every second week. So the first one was on the second week, then on the 4th week, then on the 6th. Yes, of course. So let's do this. I'm gonna stop share and stop the recording, and in the last 3 minutes, we can just unmute ourselves. Give me 1 second.